Hello everyone, welcome back to a new OK video. My name is Omar and let's jump right in. In this video, we'll be solving this problem, unique path. For this problem, we have a robot in a grid. The robot is placed in the top left corner and it needs to reach the bottom right corner. The robot can only move right or down. What we need to know are the number of unique paths or ways the robot can reach this target. The obvious solution would be let the robot try a path using his allowed movements. Once it reaches the bottom down corner, this is considered as a path. In a systematic way, we can let the robot try all combinations until we know all the possible paths. Well, this is not efficient. The reason is the robot, while taking different paths, can have common subpaths which are represented in red here. This part is recalculated in both paths. In big grids, the common parts can be common in hundreds of paths, which makes us redo the calculations. Since this problem can be represented as subproblems which are overlapping, we will be using dynamic programming to solve it. If you do not know what is dynamic programming, you can check it in my other video. I will leave the link in the description. Well, for dynamic programming, we need something that represents the current state. In our case, it will be the grid cells. At each cell, we save the number of unique paths to reach this cell. So how do we combine to previous smaller states? We know from the question that the robot can only move down or right. So to reach this cell, we must have came from the top cell or the left cell. So simply adding the number of paths to come from the left and the number of paths coming from up will give us the number of paths to reach this cell. Now going to the base case. What is the smallest problem which we can have? Yes, it's a 1x1 grid where the start position and the goal are at the same place. There is only one way to reach the goal then. But actually the base case is not only at this cell. To reach any cell in the first row, there is only one way you can do that, and that is by going right. Not only the first row, but also the first column. So any grid of one row or one column is considered a base case too. So now we have all the puzzle pieces. If we start from this cell and apply our rule, then we will have our solution in the bottom right cell. So let's implement what we just said. We initialize the grid by ones, so we can have that base case in the rows and the columns. And then starting from the second row and the second column, we do our step. And finally, we return the value in the bottom right cell. Yeah, this question is just solved in these 5 lines of code. So let's test this code. Looks fine. Let's submit. And it is perfect, and you can see the good performance. That was it for today's video. See you in the next one.